Bismillahirrahmanirrahim. Hello everyone, I hope you are all doing well. In this short video, I will try to show you how we can create a seismic velocity model from which we can create synthetic gathers or theoretical gathers that we can process, and we can apply certain processing operation that we have learned in the class, and then we can do the animal correction and velocity analysis and also stacking and migration. So initially, we need to go to velocity modeling. So in the velocity modeling, we can create a velocity model based on our interest. So if we are interested in certain type of geological structures, we can just model them here. So this is the extension of the model in the X direction, and in the depth direction, it's from 0 to 1000 with an increment of 10, and depth is the same, and they can change it as I want. So here I can define what will be my background velocity. For example, in my case, it's 1500. You can make it more or less. And I can add now any object. It can be, and the object can be geological layer, geological structure, cavity, or whatever I want. For example, I want to add the first object, which will be a geological layer with 2000 meter per second, and I will add it to my model around 300 meter. Okay, so I will come here and I will make it around 300 meter thick. Okay, then I double click, then this will be my velocity. I see that some gap here. You can easily add it, add another object which will fill it. Okay, like this. I can add, I can repeat the same velocity and create maybe another layer in case, for example, I have interbedding in my area. Means I have many layers which are having the same velocity. I can add another one, or I can add another object which may not be maybe a geological layer. Okay, so this is the second layer. And if I'm not happy and I want to add more layers, I can just go and add another layer with 3000, for example, meter per second. And I will add another object. For example, I'm not interested in the interbedding. I want to replace it with another geological layer. So with a very thick one. And for simplicity, I will make only these three layers. So one low velocity layer, and the second is medium, and the third one is a little bit high velocity model. If I'm happy with this model, then I can go and save my model. So this will be my velocity model, which will be named. So for example, I can name it lab, for example, 01 velocity model. I will make a prefix for all what I will create now. Okay, now it's done. This is my velocity model. I go to refresh here, and in the refresh, I can find my model here. Now I want to create or to see seismic shots. And if I want to create, for example, VS and density models, I can just load my velocity model and load also the S wave and the density for each layer, and I will duplicate that model and with the same structure but with different values, which will be the S wave and the density. But in my case, I don't need. Now I go to my shot gathers. I will try to create shot gathers. Okay, so here I will have this is my source coordinate. At every 20 meter, I will have one source, and I will do the same thing for my receivers. And for example, I will leave the time axis or the recording length to be 1.5, for example. And then I can bring my velocity model, which I just created, and then I can run. So this is my shot gathers. First shot, second shot, third shot, and I see here I have primary. And after this primary, I have many multiples. I have here the second primary is here. It's quite strong. It's very clear. Okay. So once I'm done with the shooting, which is this is what we do actually in the field, then we can move to the seismic data processing. Okay, now we are done, and now we can go to save the gathers. So these gathers, I will also give them a prefix. We have 01, and this will be my gathers. This is row gathers. Okay, then I will save it, and then I will. So when I use prefix, so all my data will be ordered one after one. Okay, now these are the gathers. Now what I can do, I can go to the processing menu. So here I will start by the AGC. The AGC is the amplitude gain correction, the automatic gain correction. I will bring my gathers. So gather 00. And then I see that the reflections are not visible. Why? Because I have very large dynamic range. I have very high amplitude here, which makes the other amplitude very weak. So when I do the AGC will help me somehow scale the gathers so that they will be visible. So this is, for example, how the gathers will look like after the AGC. So it's like I'm giving an importance to all the amplitude in my shot. Then if I'm happy with this value, and by the way, this is a window, time window, which is, so I will open a window of 1 second along which I will normalize my amplitude or rescale it. I can make it shorter, but when we make it shorter, usually it will amplify too much the amplitude, which will not be healthy. So, and we can make it even less. So I can make it 0.5 or 1 or less. So let's keep it 0.5 and we will apply it on all the gathers. And then I will save it. So this will be my L02. So L02 now it will be after the so I will be knowing and I will be able to know which one comes first and which one comes next. So this is the AGC. Okay, now what I can do, I can go to the sorting and stacking. I can stack, for example, my data, and this will be like um, it will be like row stack. So here I did nothing. I just stack everything without any proper processing. So I did not apply proper processing. So I can start seeing my reflections here. So this is one of the reflection, and this is the second. And all what is in between is multiples, and what is above is noise. Okay, so I can save this stack. This will be a row stack. Row stack means we did nothing. Okay. Now we can go to the velocity analysis, or we can go to the FK filtering first, or the bandpass filter. Let's try the bandpass filter. The bandpass filter will help us to clean the data from any possible noise. Okay, so And the good thing is that at this stage, the program will sort internally the short gathers to CMP gathers. Okay, let me try to apply this bandpass filter. So the bandpass filter, as we learned, it will allow certain band of frequency to pass and will kill the rest. So for example, this is the default. So from every frequency from 5 to 7 up to 20, 30, it will be normally treated. The rest will be killed and will be suppressed. So let's test and see if there is any improvement. Yes, there is some improvement. Some of the noise which is here is already attenuated. So we can make it, for example, instead of 20, 30, we can make it 25 and see if there is any improvement. We see that there is better smoothing and the better maybe result. So if I apply this band frequency, so I notice that I can have a better signal to noise ratio. So some of the noise which was here now is already out. And I can see that I have my primary is better here, is better, it has better visibility, and its multiple also is very strong. The second primary, which is here, now it's also better compared to the row. Okay, so I will keep things like this, and I will apply on all the data, and I will export it. And this will be my L03. Okay, then I will go to next. Okay, then for example, I'm interested to apply the FK filtering. So the FK filtering can bring my my BP data. So here it's better than the raw. Of course, I can bring the raw, for example, if you want to compare. Where is the raw? The raw is here. Now I will bring the one with the AGC. So here you see there is so many noise compared to the one after the BP. This one is very much cleaner. Okay, then here I will define what are my parameters for the FK. So this is the FK. So here I have some noise and some reflection that I have to clean, and some of them that I have to keep. Okay, so I can go to other maybe shots or CMPs. I go to the one in the center. So the CMP in the center, it will show me, for example, the two sides of my shot, and they can see the FK. So in the FK here, I see that I have two sides. So one from the right and one from the left, and the noise, which is the reflection, is in the middle. So for example, I can test and I can define a polygon. And in this polygon, what I will do, I will assume that this is noise, and I will try to kill it and see what will happen. I will go to please reject this noise or suppress it or remove it and click on FK. Now I see that this noise is fully attenuated, but unfortunately part of my signal is also killed. So it means that FK now is very dangerous, and I cannot apply it at this stage because there is no clear separation between my signal and my noise. I can do, for example, another option. I can um, let's delete first this polygon. And we try to define another polygon. For example, let's say, according to what we learned, usually the reflections will not be linear and they will have an aerial extension, not a linear extension in the FK domain. Why? Because they don't have regular slope. Let's suppose that these are my reflections, and then we try to pass them, not to kill them, and see what will happen. So the program is still working and it's not responding. So let's delete polygon and we define the polygon again. Okay, so I defined my polygon and now I will test it. Okay, so I passed this part, but it looks like some of the noise is also interfering with my reflection here. So as a conclusion, because the noise and the signal, they are sharing some frequencies, so it means I will not be able to differentiate them. So now here, for example, I can do a trick. For example, I can reject the primaries here, but of course, some of the primaries also, some of the direct waves, it's clear that some of them also, they are gone with the primaries. So what I can do, I can subtract one from the other, but I don't want to complicate things. So I can conclude or I can decide to do not apply the FK as it will influence my signal. So it's not recommended. So now I go to the next step, which is the velocity analysis. Velocity analysis, I can find it in pre-stack processing. So this is velocity analysis, and the velocity analysis, I can bring the gathers after the BP. Then these are the gathers, and this is the velocity spectrum. So here I have I can take some peaks for my velocity. Okay, like this, like this, and like this, and then I hit enter, so I can see the flattened targets. And if I'm not happy, I can just do it again. And then I will have better flattening. So we have very nice flattening here. I can save my peaks. Okay. Then I go to, I can make my step, for example, let's make 5. Then go to next. So here you can define another velocity, can pick another velocity. And one thing I notice is that my velocity semblance or my velocity spectrum is improved and I have a higher resolution than before. Why? Because I have more traces in my CDP gathers. Now I can save my peaks. I see that here flattened, curved, but here is flattened after the animal. I can save my peak and then go to next. Next, now I see here I have better quality of peaks and energy. Why is that? Because this is because I have more traces in my CDP gathers. I go now, peak. And here now I have a better flattening. And I can save my peak. Then I can go to next. And then I can peak velocity. I have better peaks. And then I can save my peaks. Now I can pick more. For example, I will pick here. Okay, I will save my picks. Okay, and then um, so once I'm done with my picks, then I can go to the next step. Now, once I'm done with my peaks, so as I did in the velocity analysis, so once I'm done with my peaks, so here I have see my I can see my enamel correction, my CMP gathers before the enamel corrections, and here after the enamel corrections, I save my peaks and then export them. Now, what I can do, I can go to build my velocity model uh, from the peaks. So I will firstly load peaks and then load the stack, which I created, and then I can build my velocity model. So this is my velocity model, and I notice that here I have some missing uh, areas where I do not have peaks because it's at the margin. So I can go and pick here if I have a better quality of shots or CMPs. If not, then if I'm not interested, then I just go to or proceed with this model. It's clear here that I don't have peaks. So if I have peaks, then everything will be interpolated. That's why it's highly recommended to start shooting before you reach your zone of interest, as we said in the class. Then I will save my velocity model. Give it L04, and now I'm done. And then I can go to the stacking. So in the stacking, I will apply, I will bring my gathers, and I will bring my velocity model, which I built, and then you can check. So I can check here my gathers. These are my gathers before the animal correction, and this is after the animal correction. So I see here curved reflections, and here I see flattened reflections. Okay, then if I'm happy with the quality of my peaks, then I can just stack. So this is my stack after the animal correction, and I can save my gathers and my animal corrected gathers. And I can save also my stack. So here I will name them L05. Okay, so now I'm done with my stacking, and I can, for example, go to run the migration. I know that the migration will not do anything else, will not add anything. Why is that? Because we already have our data is flat and is horizontal, so it will add nothing. So here, this is our first reflection. This is our second reflection, and in between there are some multiples. Okay, if we run the migration, then the migration will not displace any target. Why? Because they are already horizontal. So the migration is recommended, especially for um, data which is not flat. Okay, so we run here, we load the velocity, and here then we can just run the migration. Okay, and once we are happy with our final result, sometimes we can apply some post-processing tools or post-stack tools like the decon, like the BP. So we can apply again the BP, and we can apply the FK also after the stacking. So for example, I can load my stack, my final stack here. I can draw it in the FK domain. For example, I can make it a domain like this. So in the FK, we know that everything is flat. We'll have an infinity or slope, an infinity slope. So this is the zero slope. This is, for example, 1, 2, 3, 4. This one is the infinity. Why? Because um, you have delta y divided by delta x, which is 0. So what we can do here, we can, for example, draw a polygon around this flat areas. And then we can pass it this time. We'll not reject it. If we apply the FK, then some of the noise which is you see here and here will be out, and we'll keep only the main reflections, and we can save our data after the FK if we want. Okay, so I think, and lastly, if you are happy with your results, then what you can do, you can export it in a SegWi format, like the one which we explained in the class. So this is my stack after the processing, and here I can show what is my sampling rate should be in millisecond, and what will be the time. So the start time, for example, if it is 0, then I put it 0, then export as SegWi format, and then I will name it, for example, uh, processed data here, then I will save it. Okay, then it's done. Last thing we can do is to create a seismic section directly from the velocity model that we have built in the beginning. So this is my velocity model, and here I have to define what will be my uh, space increment and my depth increment, and what is my sampling rate for the seismic, and what is my recording length, and they can run my seismic section to generation and see how the seismic should look like. So here I see this is my reflection, my first reflection, which is from the low velocity to the medium velocity, and the other one from the medium velocity to the very high velocity. So this is how it will look like. And of course, so we should have ideally only two reflections and only two boundaries. So the first one is this, the second one is this, but because of the multiples, we have so many fake reflections that are not real. So one of them, or many of them, are here, for example, and some of them they are in between. So, and this is the problem of the multiples. Okay, so that's it, and thank you for your attention, and I hope you will find it useful.